For question number 33, it's given that area of the region bounded by the line y is equal to mx and the curve x square plus y square is equal to 4 to x-axis. In the first quadrant is pi by 2 units, and using integration we have to find the value of m. So let's first of all try to sketch the graph of the region bounded by the line y is equal to mx, and let's say this is our y-axis and this is the x-axis. So we have to stick to the first quadrant. Okay. Now it's given that the equation of the line is y is equal to mx. Now this equation y is equal to mx, it passes through the origin, because if x is equal to 0, this will give us y is equal to 0. So this line has the graph which passes through the origin. So let's say this is the equation of the line y is equal to mx which passes through the origin, and this is y is equal to mx. And the next is the equation of the curve x square plus y square is equal to 4, and then the x square plus y square is equal to 4 is the equation of the circle with center at its origin. We know that the standard equation of the circle is x minus h the whole square minus plus y minus k the whole square is equal to r square. And if we compare these two equations, h and k both are 0 and radius is equal to 2. So let's draw a circle with radius 2. So let's say this is the circle with radius 2 units. Now we have to find the point of intersection, because the region whose area is given is between line y is equal to x and curve x curve, that is x square plus a y square is equal to 4. So this is the region whose area is given. Okay, this is the region and its area is given. So let's find out the point of intersection of this is 0 and the radius is, this is 2 units. So coordinate of this is 2 comma 0. The x-axis and the point where the circle intersects is 2 comma 0. Let's say this is point A and this is point B. Okay, now let's find the point of intersection of the circle and the line. So line's equation is y is equal to mx, and circle's equation is x square plus y square is equal to 4. If we put the value of y here, so this is m square into x square is equal to 4, which gives x square into 1 plus m square is equal to 4. So x square is equal to 4 upon m square, which gives the value of x, which is plus minus 2 upon root of 1 plus x square. But because we are in the first quadrant, so the x is positive, so x is 2 under root 1 plus m square, and y is mx. So the coordinates of the point of intersection are 2 upon under root 1 plus x square in, and the coordinate is mx. So that means we can divide this region into two parts, and this point of intersection, because the coordinates of this point are 2 under root 1 plus m square, so that means this distance is, so this distance is 2 upon under root of 1 plus m square. Okay, so now the area of this region is the area of the region, let's say this is point C. So area of region OAC plus area of region ABC. So area of the region, the complete region is OABO. OABO is equal to, or let me write it this way. So let's say the area of the region OACO. So OACO So OACO plus area of region ABCA. This one, area ABCA. So this is given it's pi by 2 square units, and we have to find the value of m. Now area of region OACO, this lies under this curve which is y is equal to mx. So this is, we can find the area of this region OACO using the integration 0 to 2 upon under root of 1 plus m square into y into dx plus this is the next region is formed here to this coordinate, this length is 2, so the area of the region ABCO will have the limits 2 upon under root 1 plus m square to 2, and its y into dx is equal to pi by 2. Now we have to put the respective values of the y. So this region is under the curve y is equal to mx, so y here is it's under root of 0, 2 upon under root of 1 plus m square, y is mx into dx plus this is 2 under root 1 plus m square to 2, and this region is under the curve, that is the equation of the circle. From here we can get y is equal to 4 minus x square, so we can write the value of y which is under root 4 minus x square into dx is equal to pi by 2. Now m is constant, so it's out, and we are left with x. So integration of x is x square by 2, and it has a limits 2 upon under root 1 plus m square 0 plus. Now this is of the form a square minus x square. So under root a square minus x square, which is integration of under root a square minus x square is x by 2. So this is x by 2 under root a square minus x square plus a square by 2 sine inverse x by a plus c. We are going to use this for the formula here, so which gives it's x by 2, so it's x by 2 under root of 4 minus x square plus, okay, this is x square, and next is a square by 2, so a square is 4, so 4 by 2 is 2, and it's sine inverse x by a, which is 2. So this is actually, we can write instead of 4, we can write here it's 2 square, and we have used the formula, and this has to be evaluated for the limits. The limits are 2 under root 1 plus m square to the upper limit 2 and pi by. Okay, so let's simplify this, and now this is m into n x square, so 2 is out, and x square is 4 upon 1 plus m square, so this is 2 plus, if we put 0, this is 0, and this has to be evaluated for, let's put in the upper limit first, so 2 by 2 is 1, and this is 4 minus 2 square is 0, so this is 0 plus, this is 2 sine inverse 2 by 2 is 1 minus, so we have put the value, the upper limit in this, and now we will evaluate it for the lower limit. This is 2 upon, okay, this is 2 upon under root of 1 plus m square. Now if I put here, this is x, 2 upon under root of 1 plus m square by 2, 2 and 2 gets cancelled, under root 4 minus x square, so this is 4 upon 1 plus m square plus 2, this is sine inverse x, x is 2 under root 1 plus m square by 2 is equal to pi by 2. Okay, now This one is 2m upon 1 plus m square, and this is 2 sine inverse 1. Sine inverse 1 is pi by 2 minus. Let's open up the bracket. So this one is now 1 upon under root 1 plus m square. I'm not going to open the bracket. So this is, if we take LCM here, so this is under root 1 plus m square, and this is 4 plus 4m square minus 4 plus 2. Now 2 and 2 gets cancelled, so this is 2 sine inverse 1 upon under root 1 plus m square is equal to pi by 2. Okay, so 4 and 4 gets cancelled. I'm going to open the bracket now. 2 and 2 gets cancelled, so finally we have 2m upon 1 plus m square plus I minus. So under root 4m square is 2m, and under root 1 plus m square into under root 1 plus m square is 1 plus m square minus 2. This is now, we have opened up the bracket, so this is minus now, minus 2 sine inverse 1 upon root of 1 plus m square, which is equal to pi by 2. Now this terms gets cancelled, and finally we have minus 2 sine inverse 1 upon under root of 1 plus m square, which is equal to pi by 2. Let's shift pi by 2 to the pi to this side. So this is pi, and this is now minus pi by 2. So minus and minus gets cancelled. So this is now sine inverse 1 upon root of 1 plus m square is equal to pi by 4. Now we know that sine inverse 1 is pi by 4. So instead of pi by 4, so instead of this pi by 4, I can write sine inverse 1, because sine inverse 1 is pi by 4. Now sine inverse gets cancelled. So this is 1 upon under root of 1 plus m square is equal to 1. And if I square on both sides, this gives me 1 plus m square is equal to, this is under root 1 plus m square is equal to 1. And if we square on both sides, this is 1 plus m square is equal to 1. And m square is equal to, okay, let me check the values once again. Okay, so this is sine inverse 1. Okay, pi by 4. This is, okay, we know that it's sine inverse 1 by root 2. That is pi. So sine inverse 1 by root 2 is pi by 4. It's not sine inverse 1, sorry. So this is now 1 upon under root of 1 plus m square, that is 1 by under root 2. And if I square on both sides, this gives me 1 plus m square is equal to 2. So m square is equal to 2 minus 1, which is equal to 1. And m is equal to plus minus 1. But it's given in the question that m is greater than 0. So find the value of m. M is greater than 0. So we will ignore or reject the negative value. So it's, we will write that m is equal to 1 because it's given that m is greater than 0. So this is the value of m, which is 1 for question number 33. And let's move on to question number 34.